So talking about cross-border thinking, this is my hero, or one of the heroes, especially the hero of cross-border thinking, Leonardo da Vinci. I think you all know him of his beautiful painting, the Mona Lisa, but he's also known, maybe not so well known, but for his sketches. He thought about all things that interested him, and he was very broadly interested. So he crossed borders in his mind. He was interested in how the human works, or how our physiology works. So he actually dissected human corpses to see how that worked. He was also interested in technology, so he came up with all kinds of designs, and thinking that he lived 400 years ago, approximately, he came up with airplanes before most people ever thought about it. So that's a huge inspiration, and Leonardo da Vinci is what we now call a Renaissance soul, people who cannot focus on one part. And I try to be a little bit like him. So my background is in engineering. I studied mechanical engineering, and then I ended up in a job where we did play the whole day with flight simulators. This is an example of one of the flight simulators I worked on, and this is also in Leonardo's mind human-centered engineering. That means that we look at the human and we look at the engineering part, so the technology, and how do we combine those. And in a simulator, this is perfectly combined. You have a pilot in a simulator which is trying to learn how to fly, so he interacts with this machine. And the purpose of this machine is that he stays safe and that he feels like he's really flying a real aircraft. So it's really human-centered engineering. So then I moved into robotics, and this was a coincidence. A customer, I started my own company, a customer asked, "Can you build a robot?" I said, "Yeah, sure." Not realizing how complex that was. But you just start and you kind of deduce down the complexity of things and replace them with things you understand. So we designed, the goal was to design a cheap robot that was for small, medium enterprises. So let's talk about robots. And if you Google the word robot, it shows up like in its human form. So a robot looks human, according to Google, and maybe according to most of us. So if you hear the word robot, you think of something with arms and legs and a head and some intelligence. But actually, that's not the real truth. 99% of the robots look like this. They're in a factory. They're kind of brainless machines. They're actually really dumb. They just do repetitive tasks. They're very good at it. They're very accurate. And they're very strong. And they don't complain. But they're very dangerous. And that's a problem. So we put a big fence around it. You see on this picture that there's a fence to keep the humans out, because if you go in there, you might be killed. But today, this is still how robots look in the real world. So they don't have arms and legs and heads, and they don't have intelligence, not at all. So looking at this historical way of automation in general, so not only at robotics, we see that in the 19th century, we moved from craft to series production, small series, and that evolved into early last century into mass production. Think of Ford. You could buy a car as long as it was black, and so it was actually Ford pushing the same car to the market. Instead of, I need a suit, please make me a tailor-made suit. That's the pull of the market. So now we're at this peak of mass production. So we get our products from low-wage countries like China, and they push these products toward us. But we're not satisfied as customers anymore. We evolve further, and we'd like to have this story with this product. So craft beers, they are upcoming. The craftsmanship is coming back. So that actually means that there's a big opportunity, especially for small businesses. But we have to learn to cope with this demand of the consumer who wants mass product prices, but individualized products, so personalized production. So how are we going to do that? So everybody wants their own cookie, basically. So individually, today I want a cookie shaped of a hand, tomorrow I want something different. And I want it now. So we need some kind of revolution for that. And we're kind of at the start of this next revolution that's called Industry 4.0 in Germany. And it's called Smart Industry here in the Netherlands. And this fourth industrial revolution came from way back when we mechanized production, then we switched to mass production, then we use computers to automate things even further, and now we connect all these things together to end up with cyber-physical systems. So there's a cyber world, which is, you could call that the internet, and the physical world, which has to do some action on a product. So there's also physics with it. And robotics fits perfectly into this story. So, but what are now the real technical challenges if we want to end up with this fourth industrial revolution? What do we have to do? Well, first of all, I put safety there, because as you saw, these robots are kind of mindless machines. They don't even notice you when they kill you. So safety is a very big thing, especially if you want to involve robots in smaller businesses. And I put communication second, but actually that's the enabling technology to make all this happen. So we need to communicate with machines, and the machines need to communicate with each other. Then having this enabling technology of communication, you can think about usability. How do people better understand robots? Telling them what to do, not how to do it. And drive and control. That means that we build robots, not like we build industrial machines, but maybe like we build vacuum cleaners, which is highly integrated. So we combine electronics, mechanics, and software into one little package. And everything gets smaller and smaller and gets shrunk into a mechanical part. Then, of course, there are sensor systems, navigation, artificial intelligence, which you could connect to all these communicating devices. And efficiency. Think of mobile applications, more and more driving robots. I won't talk about walking robots yet, but let's start with decent driving robots. And then you need long battery life, so you need efficiency. So go back to these cookies I showed you. So you have these small business, two guys making delicious cookies, and they can make individual cookies for you. And they can do it today, so you have them tomorrow. And they now need to grow their business. They need to lower their prices because the customers demand it, because otherwise customers are going to buy cookies in China, but they're not individualized, but somehow you compete with that. So how would these guys, they get together. How would they do it? They get together, they decide, okay, we're going to buy a robot. Then they buy this thing, and it looks really scary. They have this panel, they look at it, and they actually have no clue how this should work. How can they ever do that? They need the guy in the white collar guy, who is the expert. He's an engineer. He studied in the region here, RWTH Aachen, and he comes and does it for them. But then they say, okay, I've now made a bunch of cookies. I now need to reprogram my robot 2 hours later because there's a new batch coming. So they call up this guy. We better stay there because they're going to change this program all the time. So you see that this is a huge problem. We cannot afford this kind of technology that we have today. We have to come up with something new. These guys, they want a robot that they tell him what to do, not how to do it. They should be able to tell this robot, okay, we have cookies here, they need to be in a box, nicely in a package, and you need to close the box and put tape around it. And then maybe even stick a label on it. So that should be the programming instruction for the robot, and the robot would solve this automatically. So the task of us robot engineers is to take away this complexity, hide it somehow. And there comes cross-border thinking. So we have, on the right-hand side, we have this established company, Siemens, you maybe know them. They're actually the biggest control system provider in the world. Huge company, very good, reliable products, fantastic. And then you have Beckhoff, which is kind of a newcomer in this field, but also already a big company. They're the most progressive companies in industrial automation. So they make control systems for machines so that they can produce things. And on the other side, you have Google, Facebook, and World of Warcraft. World of Warcraft is an online game, massively online game. And you can, with thousands of people, you can simultaneously enter the same game domain and play together. So that is a complete other way of thinking, connecting so many users together. You need quite some technology to do that. And funny enough, these kind of worlds are separate. So the world of Google, Facebook, and World of Warcraft, they don't know about the machine automation world. And vice versa, they think it's kind of inferior to use this technology because we need this quality to keep our production up. So we're about to tear down this wall. So let's go back to Leonardo da Vinci. He's cutting open corpses. We show a brain. So we look at how does the brain do all these things. So you have a higher level brain, which is actually your conscious. So it's the neocortex, often associated also with artificial intelligence. So there's a lot of companies thinking of creating an artificial mind, which can actually consciously think. And this neocortex gives command to the motor cortex. And the motor cortex is the part of the brain that controls your arms and legs. And actually has learned, since you were a baby, has learned certain skills. And these skills are, for instance, walking, picking something up, keeping your balance. And we all do this subconsciously. So this motor cortex does things, and we don't even notice it. So let's take this biological thing and translate it to something technological. So that's what we try to create. So we try to create a machine motor cortex, which is kind of taking, it's very low level. That means that it's very close to the hardware, close to your arms and legs. And it has some brain of its own. So it can understand like high level commands, like walk forward, open the door, things like that. And this motor cortex should take care of all these low-level control things. And if you combine that with this internet technology of connecting everything, you get something that can be connected to each other, and you can connect it to the web, and that opens a lot of possibilities of new applications. Like you could do analytics on your machine. Imagine you have a machine or a robot, and you would like to know at this moment, what is my power consumption of this axis of this robot? If I collect all this data, you're speaking of huge, big data. So we could ask IBM to lend us their Watson computer to analyze all of this data and come up with a nice answer. For instance, my robot is going to break down in the next 2 weeks, so you better replace it. And then I can replace it in the weekend when I don't have production, so my production is not cut off. And also this nice thing about this motor cortex would be that you could directly access it from any browser. The web browser is kind of the universal programming environment for a lot of people. A lot of people, maybe some here in this audience, they know how to build a website and create a user interface, actually. So there's a lot of user interface and user interaction designers out there that could use this technology, which are not from the industrial world, to create new interfaces for people that people really understand. So this is our main effort, and it's not only an idea, we also did it, and we also test it with a team of highly qualified 4- and 5-year-olds. Because we think these have the kids, they have the most clean mind, and if they understand it, that's probably a good design. We also get influenced by teaching tools for kids, which employ a lot of the methods that we actually should employ for machine control systems to make it easy for grown-ups to use machines without prior knowledge. So this is actually my son. He plays with them a lot, so he's not a good test subject anymore because he had too much practice. But you could see that some of these ideas that are coming from the gaming world, so these kids, they use phones and tablets, like it's their second nature. And they're already so used to these elements on the user interface that we should use that instead of the classical buttons and keyboards. So this was a very early experiment. Now we are actually, this is more our state of the art, where we really have a multi-touch, beautiful to look at user interface that actually is relatively easy to use. We're not there yet, I will admit that. But we now have a starting point of where we can design our user interfaces further. And we hope that by doing all of this, so starting with this Machine Motorcortex, which enables communication to the web browser, which creates possibilities to make better user interfaces, to connect to artificial intelligence on the web, that this is actually the enabling technology that will enable the small businesses to become competitive in the future. And so that's also important for this region. Because we want to attract more and more businesses. And the small businesses, I think, have the future. Thank you very much.